In this video, we'll add audio to our VR game. There are two different sound effects we'll add. The first is a glass shattering effect that will play when the glass bottles shatter. The second is a popping sound that will play when the bottles reappear. We'll also be adding in the script that actually makes the bottles reappear after they're destroyed. Audio in VR is a little different to how it's done in non-VR games. When our goal is to immerse the player completely into the game, we spend a lot of time making sure that the visuals are completely immersive. But we also have to spend a lot of time making sure that the audio is as immersive, because it can really draw the player out of the illusion of immersiveness if the audio isn't up to scratch. Part of how we do this is via a technique called audio spatialization. Audio spatialization is the technique of taking audio sound effects and calculating how they would sound if they were being played in a real environment. The human brain is able to infer a lot about the distance and directionality of sounds the ears are receiving based on minute differences in the timings that each ear hears. This is the reason why human ears are shaped the way they are. The interesting and intricate foldings in our ears cause slight timing differentiations. For example, if we hear a sound that's played directly in front of us, the ears will hear a slightly different sound with different timing patterns to the exact same sound played directly to our side or behind us, or even above or below us. An audio spatialization system can simulate these kinds of timing changes. Fortunately for us, we don't have to do very much work for this because one's already been written for us by Google. We'll have to enable it by going to the Edit menu and choosing Project Settings, Audio. Then, in the Spatializer plugin setting, change it from None to the GVR, that's Google VR, Audio Spatializer. Next, let's import some sound effects that we'll be using. We have a bottle shattering effect and a popping sound effect. Both of these sounds were retrieved from freesound.org and they're available under a Creative Commons license. Full information is available in the text that accompanies this video. Let's import these two sound effects by dragging them into the assets folder. There we go. Bottle shatter has two sound channels. We'll need to change this to be a mono sound effect. We'll turn on force to mono and then click apply. The reason why we do this is that Unity plays stereo sound effects exactly as they appear in the sound file. That is, the left channel is played directly in the left ear and the right channel in the right ear. Mono sound effects are able to be interpolated and placed into the scene in 3D. Next, we'll add the component that plays the sound. We'll add this to the glass explosion effect so that when the glass explosion appears, the sound effect is played. Select the glass explosion prefab, scroll to the very bottom, and click Add Component. Type GVR audio source. A GVR audio source is a variant on the standard audio source component that Unity provides, but it makes use of the spatialization system that Google VR contains. We'll drag our bottle shatter into the audio clip field. In order to be able to hear the sounds that come from a GVR audio source, we have to add a GVR audio listener. This is a component that we add to whichever object has the built-in Unity audio listener component, which in almost all situations is the camera. So select the main camera. Notice that it has an audio listener built in. That's the standard Unity sound system. We'll click Add Component, and we'll add a GVR audio listener. Let's test the game. Try and throw our ball and try and hit it. Hey, first time. And there we go. We'll do it one more time so you can hear it without me talking. There we are. We're now hearing spatialized 3D audio. Lastly, let's make our bottles reappear after they're destroyed, because right now, the entire game is you can smash one bottle, and that's not really good enough. What we'll do is we'll create a new object that has a bottle spawn script on it. This script will repeatedly spawn a bottle. However, it will wait for the bottle that it has spawned to be destroyed before it tries to spawn another one. This way we won't end up with a level overfull with bottles. Let's take our bottle and make it a prefab. So we'll drag the bottle object into the assets folder and release, and then delete the bottle from the scene. Next, we'll make an empty object, game object, create empty. We'll change its icon from the empty icon to a green circle, indicating that this is where our bottles will appear. We'll click Add Component, and we'll type bottle spawn. Click Create and Add, and then double-click on the script to open it in MonoDevelop. The first thing that we'll need is a reference to the prefab to instantiate. So we'll say public game object bottle prefab. We'll have the bottles respawn in a random interval, so between 0 and 4 seconds, to add a bit of variety. Public float min spawn time equals 0, and public float max spawn time equals, say, 4 seconds. Sounds good. Additionally, each bottle spawn will keep a reference to the bottle that it most recently spawned. If this is ever null, then the bottle spawn will go, okay, now I can create a new bottle to replace it. This will ensure that bottle spawns never spawn more than one bottle at a time. So we'll say private game object my bottle. Additionally, we're going to create a reference to the coroutine that's going to be in charge of spawning the bottles. We do this to make sure that we don't start spawning a new bottle every frame that a bottle doesn't exist, because we are going to notice that a bottle has vanished from the scene. We'll start a coroutine, but only if a coroutine has not already been started. So we'll say private coroutine spawn routine. We'll get rid of the start function, and in update, we'll say if my bottle is null, so there is no bottle owned by this at the moment, and the spawn routine is also null, that is, we're not in the process of spawning a bottle, then var next spawn, so when the next bottle will appear, equals random.range min spawn time, comma, max spawn time. So we'll pick a number between these two values. Next, we'll say spawn routine equals the result of calling start coroutine, and the coroutine in question will be a function called spawn bottle, which takes the parameter next spawn. So we'll write spawn bottle next. So I enumerator, remember that's the return type of coroutines. Spawn bottle takes a float called delay. This thing in update here is saying if we don't have a bottle and we aren't in the process of spawning a bottle, and remember that takes a couple of seconds, then begin the process. The next frame it'll go, my bottle is null, we don't have one, but spawn routine will not be null, and therefore we won't kick off another coroutine. In spawn bottle, we'll first of all wait for the specified number of seconds by saying yield return new wait 4 seconds, passing in the delay. After that delay, we'll quickly check to see if my bottle has become not null. This can happen sometimes, for example, if we made a mistake. So we can say if my bottle is not null, then we'll destroy it right away. Destroy my bottle. After that, we'll create our bottle and add it to the scene by saying my bottle equals the game object, so we're casting instantiate bottle prefab, and then also set the position and rotation. My bottle dot transform position equals this transform position. Likewise for the orientation. My bottle transform rotation equals this transform rotation. Finally, and this is important, we'll say spawn routine is null. This means that the next time that we check to see whether my bottle is null, and if it is null, that is, the bottle's been destroyed, then we should be able to start a new routine to replace the bottle. All right, we'll save the file. We'll go back into Unity. Before we start the game, we'll drag our bottle prefab into the bottle prefab slot. And we'll start the game. There we go. And a bottle just appeared. And if I destroy the bottle by smashing it, after a moment, it comes back. And we're waiting a random amount of time from 0 to 4 seconds. Okay, let's make our bottles pop when they reappear. This is as simple as adding in a sound effect on the bottle itself. When the bottle appears, the sound will play. We'll select our bottle object, and we'll add a new component, a GVR audio source, and we'll change the audio clip to pop. Make sure that play on awake is turned on, and we'll test the game. There you go. Bottles now reappear with a popping sound. We can make this game more interesting by adding in more walls and more bottle spawning points. We would do this by duplicating our wall by selecting it and pressing Ctrl D or Command D on a Mac, repositioning the wall, including maybe rotating it, and then taking our bottle spawn. I'll actually rename that, call it bottle spawn. I'll actually make that a prefab so that I can edit them all at the same time. Then duplicating it, placing it over here, maybe another one over here. And we'll start the game. So those bottles are spawning directly above the floor. We'll fix that just by going to a top view and just repositioning them so that they're not in a place where they're going to spawn and fall to the ground. Let's start the game again. There we go. And there we have it, audio in virtual reality.